So 5 for that dividing polynomials is going to really help us because all the things we've done so far, there's been some way for us to factor, but not all polynomials are factorable, or the factoring when you look at it isn't quite obvious. So this is just going to be another tool for us to split things apart. So you might recall back in Algebra 2, you learned some techniques usually for dividing up polynomials. So we're going to do two techniques. We're going to do long division. We're going to do synthetic division. So let me remind you how long division works. So let's say that we want to divide that long polynomial starting with 2x cubed by x plus 2. It's really helpful to remind you how number division works. So let's just take a look at dividing 8 into, let's go 94. Okay. So if you were back in middle school and you were trying to learn how to divide that, let's remind you the rules. You looked at how could I make 8 as close as possible, or does it go into the first digit? So it goes into 9 one time. So you put a 1 above it. Now remember, what's here, you're going to multiply. So 8 times 1, you multiply, you put underneath. And I know this is kind of silly. You should probably remember this, but it's just going to help us clarify what goes on for polynomials. You put an 8 underneath there. You change its sign so that you subtract. You bring down the next thing. And then you ask yourself, how many times does 8 go into that? 8 goes into 14 just one time, so you put it up above there. Again, we are multiplying. 8 times 1 is 8. You are subtracting. 14 minus 8 is 6. That is your remainder. That is your quotient. Okay, so now I know that's just kind of a simple, silly example, but it's just going to help us illustrate it when we do it with x's, because as soon as you throw those x's in there, you know how that goes. Okay. So if you take a look, what you're going to compare is the first one with the first thing. So kind of like we did with the 8 and the 9. So you ask yourself, what can I multiply x by to turn it into 2x cubed? Well, that would be a 2x squared. You always want to make it match. And so I said 2x squared, so it goes above the x squared. Okay. Now, the way you know you're kind of starting out right is if you multiply that by that, and because of our rules of multiplication of polynomials, we have to distribute and multiply by that. When we multiply those things out, we're going to put it underneath there, okay? So 2x squared times x is 2x cubed. Your first thing should always be a perfect match. Now, the next thing usually won't be, but it might be. Now, we're going to do 2x squared times 2, which is positive 4x squared. Now let's revisit what we did here. We multiplied, we've multiplied. We put the number down there, and then you'll notice we put a negative in front. Well, to subtract a mathematical expression, you always have to add the opposite. So just change both the signs to the opposite. So we are subtracting that expression. We will add the opposite. So 2x cubed and negative 2x cubed, the first term should always disappear. That knows that you're on the right track. Negative 3x squared and negative 4x squared is negative 7x squared. And just like here, we brought down the 4, we're going to bring down the next piece. Because our initial thing had 2 terms in it, we should always bring down 2 terms at a time. Okay. So, and now we're going to do it again. You're going to compare x and negative 7x squared, similarly how we did the 8 and the 14. Well, what would you multiply x by to get negative 7x squared? Would be negative 7x. You'll notice our power went down by 1. It should have. That's good. Okay. And now we're going to multiply and distribute that to both of those. Now you have to do it by both. It was a negative. So negative 7x times negative 7x times x is negative 7x squared. Those should be an exact match. And then negative 7x times 2 is negative 14x. But in algebra, we are subtracting, so change the sign of both. Change the sign of both. So the negative 7x squared became a positive. Perfect. It's going to cancel. It should always cancel out that first term. 4x plus 14x is 18x. Bring down the next thing. Let's do it again one last time. X needs to go into 18x, so what would I multiply x by? 18. That goes on top. We are multiplying, so it is going to distribute to both of those things. So you get 18x, should be a perfect match. 18 times 2 is 36. That does say plus 36, can't you tell? And now, remember, whatever you put down there, you are subtracting. And in algebra, that means add the opposite. So both of those things become negative. Now, positive 18 and negative 18 should always go away. 5 minus, that does say minus 36, is negative 31. And that's our remainder. Okay, and this is our quotient. And this thing here is our divisor. Okay, now see this little thing that says right here, the dividend equals the divisor times the quotient plus the remainder. If we wanted to check our work, the original 2x cubed minus 3x squared plus 4x plus 5, the original thing inside. If we did x plus 2 times 2x squared minus 7x plus 18, and we subtracted 31, we should get the original. That is one way that you can check your work. The quotient times the divisor plus the remainder, and now it was a minus 31, so when we add a negative 31, we're subtracting. But this should be your original thing inside. If it wasn't, you did it wrong. Okay, if it wasn't, you did it wrong. One quick little check that sometimes is kind of nice to check. 2 times 18 is 36, minus 31 is 5. Just checking that little constant at the end is a really good way, because if you got all the way to the end and had all those things right, it's just a really quick way to check your work. So let me tell you again, positive 2 times positive 18 is 36, minus 31 should be the constant you see there, the 5. Okay, and you can see they've written it out as well. Okay, so so that's long division. So hopefully that helps you remember some of those division techniques that from back when you were little. Let's do another one, because the more we practice at this, the better we're going to be. So you're going to put the x plus 1 on the outside. Now, here's where you have to be careful. If a term is missing, it is not naturally there like in our number system. If there's no hundreds, there's a 0 there to hold that placeholder. We don't have any factors missing, terms missing. So here, what do I mean? That's an x squared, that's an x to the first, and that's a number. If they didn't go down sequentially like that, we may have to put a 0, so watch that. Okay, but anyway, we can just write our 5x squared plus 3x minus 2 on the inside. So what are we going to compare? Well, x, what would we multiply that to turn it into 5x squared? That would be 5x, so put it above the x. Keep yourself organized, keep yourself lined up. And even for me, it's hard for me to make it nice and pretty and perfectly lined up, but the more you keep it lined up, the more generally you won't mess things up, okay? So remember, that's going to multiply by both of those terms. So we're going to get a 5x squared. That first one should always be a perfect match. 5x times 1 is positive 5x. We are subtracting, so change the signs of both. The first term should always go away. 3x minus 5x is negative 2x. Bring down the negative 2. Do it again. What times x would give me negative 2x? Negative 2. So we have negative 2x minus 2. But we are subtracting, so we change the sign of both. And we have a 0 remainder. Now, what's really cool about having a 0 remainder is that means that this thing here was factorable. It had a factor of x plus 1 in it and a factor of 5x minus 2. Division is a way for us to factor. Division is a way for us to break it up. Same idea. If I had the number 6 and I wanted to divide by 2, I would have a 0 remainder because it goes in exactly 3 times. That means 6 is 2 times 3. It's the same idea here, okay? So that shouldn't be a shock to you. That should be pretty straightforward, okay? Let's do it again. Let's do it again. So it says to divide 6x squared plus 49x plus 54 by x plus 7. So we're going to put x plus 7 on the outside. We're going to put 6x squared plus 49x plus 54. Do you see how the powers go x squared, x to the first, and no x's? If anything is missing, we have to account for it. Put a 0 in whatever spot is missing, wherever every spot is accounted for, so we can do our division. Okay. So what times x would turn into a 6x squared? That would be 6x. Put it up here. We're distributing, so we're going to multiply by both of those. We get 6x squared plus 42x. We are subtracting, so change the signs of both and combine like terms. The first term should always go away. 6x squared minus 6x squared. Bam, gone. Perfect. 49x minus 42x is 7x. Bring down our 54. Do the exact same procedure again. So what times 7x would give, what times x would give us 7x? That would be a positive 7. But we're distributing to both pieces. When we do that, we get 7x plus 49. We are subtracting, so change the sign of both. And our remainder is 5. So it says to give the quotient and the remainder. The quotient is going to be 6x plus 7. The remainder is 5. If you have no remainder, put 0 there. Yes.
If you have like, so if the negative 6x squared, right, is a negative, and then you get, you would have to get the negative 6x squared, right?
Yes.
And then what if the other one was positive? So you would have to change the negative 6x to positive, but would you change the other to negative?
Yes, so whatever you put underneath there, whatever their original signs are after the multiplication, both of them change. So if one is positive, make it negative. If one is negative, make it positive. Whatever it is, switch both of them. Correct. They're not always going to be the same sign. That is correct. Any other questions about that? Okay. Okay, let's keep going. So we're going to put 5x squared plus 4x on the outside. Now let's check. You really have to check this part. This part, at least it has to go in order. I know we don't have any constant there, but as long as the first one goes in order, the second one can't miss anything. So we have a 3, a 2, a 1, and a number. So we're good to go. Okay. So you ask yourself, x squared, I only need one more x to turn it into an x cubed. To turn the 5 into a 15, I need a 3. So I need a 3x. Now look what's great. We have jumped all the way down there. So we only have 2 steps to this division. So actually the higher powers look funky, but you get done a little quicker. Okay, so we're going to do 3x times both of those. We're going to get 15x cubed, perfect match. We're on the right track. 3x times 4x is positive 12x squared. We are going to change the signs of both. So they're both were positive. Now they're going to both become negative. 15x cubed minus 15x cubed, gone. Perfect. 22x squared minus 12x squared is 10x squared. Bring down the next thing. Okay. So now you ask yourself, what times 5x squared would be 10x squared? That would be 2. Now we're going to distribute to both things. And so we get, let's see here, we get 10x squared plus 8x. We are subtracting, so we change the signs of both. We get negative 35x and then a negative 21. Bring that down. Now, that whole piece is our remainder because there's nothing we could multiply x squared by to backtrack and go to an x. Yes. Oh, it shouldn't be 25. Thank you. That's negative 25 if I would subtract, right? And so our quotient is 3x plus 2. Our remainder is negative 25x minus 21. You have to include that negative 21 because you didn't use it. It is part of the original. It would be something we would have to account for. Okay. So we're going to do one more, and then we're going to learn a technique called synthetic division, which can be a lot quicker. It's limited in its use. We can't use it for everything, but okay, let's do one more. So this one, we definitely need 2x squared plus 0x minus 3 so that everything lines up perfectly. I'm going to do it down here. And then the same thing's going to hold true for this. Can you see what power's missing? What power's missing? X squared's missing. So we're going to have to write 0x squared as a little placeholder. In numbers, it would be a 0 in that spot naturally, but in expressions, we usually don't write if it's a 0 in a particular location. Okay. Now, there's not too many steps we're going to have to take, which is great. So 2x squared plus 0x minus 3. Okay, so what could we multiply 2x squared by to get us negative 10x cubed? That would be a negative 5x. So it goes down here above the x. And then we're going to distribute that to all of those. Now, we need all of them because so we can line up everything perfectly so we don't forget something. So that's going to be negative 10x cubed plus 0x squared plus 15x. And here's an example where they switch signs and one becomes a positive and one becomes a negative. So that would be a positive and that would be a negative. So our 10x cubes go away. We have 0x squareds. We have negative 8x minus 5. So there is no way, or you could even think of, if I put a 0 there, it doesn't do anything. So you could put a plus 0 if you really want to. But really, right here is our remainder. You know you're done when this power is more than that power. You can't go further. There's not enough x's there. So the answer they want is they want negative 5x in that spot. And our remainder, negative 8x minus 5, goes here. Okay, so they want negative 5x in the quotient spot. The remainder goes on top of the original divisor. Okay, so that's what they're looking for if you see that in Alex. So you'll know what that particular notation is. I wanted you to see a problem like that. Okay, so that's some long division. There is a technique that's a little quicker, but it doesn't always work. We have to be careful. There is something called synthetic division. Now, I'm going to show you how I set up my synthetic division box. If your Algebra 2 teacher last year showed you a little differently, the boxes are pretty much the same. The shape might look slightly different. It doesn't matter. Okay, so the first thing I want you to do is set your divisor, that would be this thing, equal to 0. Okay, so that's the first step. And you're going to solve for x. Now, it has to be of the form x minus a number or x plus a number, okay, for this synthetic division to work. So you're going to put negative 2 in the corner of, I put it in the corner, top left corner of my box. And then I check these coefficients. You'll see how they go. X cubed, x squared, x, and a number. If any term is missing, we're going to put a 0. We have an x cubed, an x squared, an x, and a number, so we're good to go. We're going to pull out the coefficients, 2, negative 3, 4, and 5. So I make my little box like that. I think Alex might actually even like I don't know. We'll look. I think I have one like that. But and then this number, whatever it is, comes down. So now I have just set up my synthetic division box. My synthetic division box is just a placeholder for my information. I haven't done any math. I did a little bit of math, but not much. Okay. So here's how it works. You're going to multiply, write it down. So multiply -2 and 2, get -4, and then add them up. That's -7. You're going to multiply, write it down, add them up. You're going to multiply, write it down, add it up. Now, that was the very first division we had done, and we had a -31 remainder. Okay. Now, here's how you put the x's back on. Since this was an x cubed, I think of that down arrow as a way to even tell me my power goes down by 1. That's an x squared. So then just go in descending order. So our answer is 2x squared minus 7x plus 18. And how do you write the remainder? Well, you put the sign, see how it's a negative, and then the remainder over top of our original divisor, x plus 2. Let's go back to, I'm going to come back to this, but let's go back to this problem up here. Actually, that is 11 and 6/8 and 6/8. That's technically mathematically what that is. It's a fraction. That 6 is not our whole 8. It's 6 out of 8, 6/8 of the original. So that's why that looks like that, because it will follow the rules of numerical division. So you'll notice, see, our remainder is over top of our divisor. So that's just our quotient, 2x squared minus 7x plus 18, minus the 31 over our original divisor. Okay, so that's the technical way you should be writing it. So here it says use synthetic division. There's synthetic division box in mine. I'll show you how it works out. Okay, so first let's check our powers. 4, 3, 2, 1, nothing, perfectly. So you'll notice these are the coefficients, -4, 12, 18, -14, and 24. So that's just those coefficients. They took x minus 4 and set it equal to 0 and got 4. That's what's right there. Okay, so now let's do the same thing. So this one comes down, put a little plus. That one you get for free. Okay, and let's go ahead and do our synthetic division. So we are going to multiply, write it down, add them up. 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 And I put a little line there so that I kind of have a separation between my remainder and my quotient. Yes?
Wouldn't -6 times 4 be -24?
It sure the heck would, goodness gracious. 4 times -6 is -24. We have a 0 remainder, which is great. Okay, so now let's put in what we need to know. So our original thing was a fourth. So this is a cube, then a squared, then an x, then a number, and then we have a 0 remainder. Okay, so it would be -4x cubed minus 4x squared plus 2x minus 6 over, and 0 is our remainder that goes over the x minus 4. You're always catching my silly little mistakes, aren't you? Thank goodness. Okay, so their synthetic box is kind of like mine. You can add this little arrow down and a little plus sign to remind you what to do. I use a little separation there to remind me that back half is my remainder. Any questions about that one? Okay, let's do one more example. Okay, it says the volume of a rectangular solid is given by the polynomial 3x to the fourth minus 3x cubed minus 33x squared plus 54x. So that's just representing, that is your length times width times height. The length of the solid is given by 3x, and the width is given by x minus 2. Find height. Okay, so remember, length, that we want to know the height. So volume is length times width times height. Okay, so let's fill in what we know. So 3x to the fourth minus 3x cubed minus 33x squared plus 54x is, sorry, I want to scooch it, but it's not helping me. There we go. Is the length, which they told us was 3x, times the width, which they told us was x minus 2, and we want to find the height. Now, going back to algebra, if we wanted to find the height, wouldn't that just be the volume divided by the length and the width? We'd have to divide off the length and the width, right? So we just have to divide both sides by 3x and x minus 2. Now let's do the 3x first. Now here's why. To divide both sides by 3x, since this is a what's called a monomial, one term, you can just divide a 3x into all of those pieces. They're all divisible by 3x, yes. Yes, you can. The problem with multiplying first is we won't be able to use synthetic division. You can't use synthetic division unless it's x equals a number. So if it's 3x squared, we can't use synthetic division. So if you're okay with long division, you can do that. But I'm going to do it in a way that I can use synthetic. Okay, so if I divide everything by 3x, I get x cubed minus x squared minus 11x plus 18. Okay, now that's equal to that. Now we have to get the h by itself, and we can do that if we divide by x minus 2. Now, we have two ways to divide by x minus 2. We could divide using synthetic division. You can divide using long division. It is totally your option. You decide what method you want. I don't care, okay? I like if this is of the form x equals or x plus a number or x minus a number, I almost always do synthetic division. If you did multiply first, you couldn't do that, but you can, you know, there's lots of ways to do this problem. Okay, so I'm going to put x minus 2 equal to 0 to find what goes in the corner of my synthetic division box. So 2 goes in the corner of my synthetic division box. Now look at my powers. They go 3, 2, 1, nothing. So that means my x's are ready to go. So I'm just going to pull out their coefficients. 1, minus 1, minus 11 and 18. I'm going to put my separation line. I'm going to bring down that first coefficient. I'm going to put a little plus there. I have a little space so my numbers can fit in there. Okay, so now my synthetic box is ready to go. Okay, so we're going to multiply, write it down, add them up. Multiply, write it down, add them up. We're going to multiply, write it down, add them up. We have a 0 remainder, which is great. Okay, so we have a nice answer for our height. So this was an x cubed when I started. I came down a power. It's now an x squared. So my height is going to be x squared plus 1x minus 9. Now, how could you check your work? Well, volume is length times width times height. If I multiplied the length of 3x, the width of x minus 2, and the height of x squared plus x minus 9, I better get that long polynomial that they started with. Okay, so that is your example 6. Now, if you go right underneath this, that's going to be your homework. It's just division. So here I want you to try practicing long division. Here I want you to practice synthetic division. And then these two, you can use any method you want. And these ones, give them a shot. Okay, we can talk about them tomorrow. Okay, so you have the rest of the period to work on that. And then remember, there is a quiz over 5-3, a quick quiz at the beginning of class tomorrow, and it will look very much like the worksheet I gave you.